All right.
All right.
We shall now begin class. All right, so in the last couple of sections, we went over solving equations and using the addition and the multiplicative principle to solve equations, how to do those together. In this formulas section, you're going to be using one or both of those to solve for a variable where there's other variables involved. That's kind of the best way to say it. So quick announcement. The drop deadline is tomorrow. So if you feel like you need to get away from me in this class, tomorrow's the day to do it because that's a 100% refund day. After that, you have to take a withdrawal, which is not as good, let's just face it. You know, if you're wondering whether you should drop or not, come talk to me first and I'll let you know whether or not you should or not. I'll let you guys know, though I don't think anybody in this class should drop. You guys are all doing fine. Now, after the first exam, no, just kidding.
But that's true. No more after the first exam.
It's true. Yeah. It would help if I gave the first exam like today. All right. Also, a heads up, the first exam is coming up in less than 2 weeks. So today's Thursday. We'll go through next Thursday, and the Tuesday after that will be exam day.
Will you be here?
I'm actually going to be here for this exam day. I leave right afterwards. Yeah. So yeah, I'll be gone for 1 day that week.
Can I know you might have a lot of you doing work. I've asked, but are we going to still have plenty of time to do it? And is it going to be in class or down? We can do it in here.
Yeah, we'll do it in here. And yeah, just like last time, unlimited time. You know, bring your calculators, all that kind of fun stuff. You can make sure that you call me and just reschedule. It is during our regular class time, so you should be able to make it, but if you can't, just call me and reschedule. You can take it, I can give it to Conan down in the testing center. You can take it down there with him. You can just, like, I don't know, take it in one of the offices upstairs too if you want. Yeah. Oh yeah, good idea. Yeah. Make sure that you got as much time. All right, so first section we're going to go over is we're going to go over evaluating formulas. So we already went over evaluation a couple times, but we might as well go over it a couple more, just because, like I said before, there's going to be an evaluation problem on every single exam. Uh-oh. What did I do here? Sorry. Okay. So our first little bit of vocab is for a formula. An equation that shows the relationship between variable quantities, uses 2 or more letters, and is known as a formula. An example of a formula is the event promoter's formula. So this is a formula that determines what the ticket price P should be, depending on the total amount of expenses, X, and the total number of tickets they expect to sell. So this is kind of like just a thing that like an event promoter would do, and they'd say, well, I spent 20 grand on this. I think 10,000 people are going to show up. What should the price of a ticket be? You know, and they could just work it out like that. I'm sure actual event promoters have more complicated formulas than this. So for the evaluation part, it says, suppose we are expecting expenses equal to 80,000 and sales of 4,000. So I'm just going to note what these things are right here. Oh, I'm sorry, I actually told you guys the wrong thing. I think I need to read my problems closer. X is the tickets. I'm sorry, S is the expenses. My apologies. Okay, so we're going to label our variables because they just gave them to us. So they said the expenses are equal to 80,000. So we said S was our expenses. Oh, no. All right, so this is what I did. My apologies. S is the number of tickets. I just wrote down X twice. Sorry, sometimes this happens. I just wrote down the problem wrong. So this is the correct way to read it. It's right this time, I promise. Ticket price P with X dollars of expenses and ticket sales of now S. Those of you who know me know that I do that every once in a while, like every class. So, all right, so let's go ahead and label these. So they say the expenses are equal to 80,000, so we're going to write X equals 80,000 here. And then sales of 4,000 tickets, so S is equal to 4,000. All right, so now I'm going to go ahead and just sub those in for my equation. So 1.2x over S. Now this is equal to 1.2 times 80,000 over S, which is 4,000. Anybody got a calculator? All right, what do we get from that one?
96,000.
96,000. Okay, 240. You got 24?
24.
What did you get? All right, we're gonna go with the double. Can we get one? Can we get one to check it?
24.
24 it is.
Wait, we should have proof. Hold on.
All right, let's get a third on this.
Siri.
Oh, no, 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 we're not.
80,000 divided by 4,000.
Siri.
It's 24.
All right.
Hey.
All right.
Siri does that?
Siri.
Thank you.
Apparently.
I get to see people in Google.
Right.
Bye-bye.
How far is it from my house to Louis?
All right. So once again, we just plugged in what we knew the variables were worth into the formula and calculated. All right. So what happens when we're asked to solve for a variable? That basically means that we're going to write an equivalent equation with that variable alone. Guys, don't make me separate you guys. You've been so good up until this class, right? We're not in high school anymore. All right. So what it means is to basically rearrange the equation so that the variable you're solving for is on one side and everything else is on the other side. So, you know, in a different problem, if I said solve for C, this would be the answer. In this problem, they're asking us to solve for something else. Oh, and one more little stipulation. When you do that, the letter that you're solving for can't appear on both sides of the equation. Otherwise, you didn't really solve for much. So for this particular problem, this guy's asking us to solve for R. So we're going to go about doing that the same way that we would solve for x in the problem 3x equals 15. We just noticed that R has a coefficient of 2 pi, and we divide both sides by that coefficient. Divided by 2 pi, divided by 2 pi. These guys cancel out, and I have R equals C over 2 pi. And that's it. It's totally okay that the C is over here because it's asking us to solve for R, right? If it asks you to solve for R and there's 20 other variables in there, that's fine. Just leave them all over on the other side of the equals sign. Alrighty, here's another one. So in this one, the rate R at which an object moves is found by dividing distance d traveled by time t. In other words, this formula right here, R equals d over t. They want us to solve for t. All right, so to solve for t, we're basically going to rewrite this guy so that t is in the coefficient for d. So R stays the same, but we're going to rewrite the other side as 1 over t times d. And so now 1 over t is the coefficient of d. So we can get rid of that by multiplying both sides by the reciprocal. What's the reciprocal of 1 over t?
T over 1.
T itself, right? Times t on both sides.
It's just T then by itself, not T over 1.
It's the same thing.
It's the same thing.
Yeah, exactly. Yeah. So 1 over t multiplied by t, that equals 1. So those can cancel. And I have t times r equals d. Alrighty. So some of them look like this, and they ask us to solve for y. So we do the same thing as we would do usually, right? We'll say, okay, I'm going to leave y on this side and solve for it, right? So we're going to keep y on the left side. We're going to start throwing everything else to the other side. First thing I want to throw is what's attached through addition or subtraction, which is this 3x.
You want to add a 3x?
That's a positive 3x, so we want to subtract 3x, right?
Right.
So plus a negative 3x minus 3x. These guys go to 0. And I have negative 4y equals 10 minus 3x. So at this point, we're going to combine any like terms, but we don't have any. You got a question? Oh, yeah, go ahead.
So what we do is we add 4 to both sides. Or no, divide 4.
There you go, there you go.
Equals 10 over negative 4.
Negative 3? Oh, 10 over, okay. So yes, you're right on the right track. Let's go ahead and just do it, right? So negative 4 is attached to y through multiplication. We want to get rid of that, so we're going to divide both sides by it. These guys cancel out, and we just get y is equal to a negative 10 minus 3x over 4. It would have been totally acceptable as well for you to leave this negative in the denominator. That's fine. I just like to throw my negatives out front, so I did that. Okay?
That's all you can do with that. They can't go any further.
Yeah, exactly, yeah. I mean, if you really wanted to be a stickler, you could split up the fractions, but we're not sticklers at this point. This is a perfect answer. If I do say so myself. Just kidding. You're like, well, if it's not perfect by now, dude, you should probably quit your job.
Yeah.
Okay, so.
We got 2 stats. This is as much as I want you guys.
All right, so this one's straight out of the book. Actually, they pretty much all are. So the number of calories K needed each day by a moderately active woman who weighs W pounds, is H inches tall, and is A years old can be estimated using this formula. Bing. This wants us to solve for W. So let's go ahead and write the formula. So we have K equals 917 plus 6 times W plus H minus A. All right, so it wants us to solve for the W, but the W is sort of trapped in the parentheses. So what do we do to break it free? Yeah, we want to distribute that 6 in. So next line, K equals 917, that stays the same, plus 6 times W, that's 6W, 6 times H, that is 6H, and 6 times negative A, that is negative 6A. Okay, so now let's just keep our eye on the prize here and remember that this is the variable we're isolating. So, you know, there's a couple different ways we can do this. We could either take everything like this and throw it over the other side. Yeah, let's just do that, actually. I mean, the other option would be to actually throw the 6W over to the other side and then throw the K back over. Does that make sense? Okay. Maybe we'll do it that way, just because we don't usually. Okay, so I've decided that I want my 6W over here on the left side. So I'm going to subtract 6W from both sides. So minus 6W minus 6W, right? These guys will cancel out, and I'll have negative 6W plus K equals 917 plus 6H minus 6A. Okay, now that I have my 6W over on the other side, I don't want the K over there anymore, so I'm going to subtract the K over to the right side. Minus K, minus K. These guys go to 0, and I have negative 6W equals 917 plus 6H minus 6A minus K. All right, now, even though we've got a whole mess of junk over on the other side, we really just want to isolate this W. So we got to get rid of the minus 6 coefficient on front. To do that, we divide both sides by -6. And it's okay to just draw one big line and just throw one -6 under here. That's totally fine. These guys cancel, and there you go. W equals all that junk. So, no, that's junk. This is definitely not jazz. Just kidding. No, that's a good point. Okay, so let's just do it the other way around. Just, I don't know, why not? Just for practice, right? Whoa, what happened there? Okay, so let's go ahead and, okay, so suppose we had, instead of, let's suppose we approach this a little bit different. Plus 6W H minus 6A. Okay, so if we decided we were actually just going to leave the 6W over on the right side, all we need to do is subtract the opposite of everything else over to the left side.
So we take away 917.
Yeah, so let's do this one at a time, right? Okay, minus 917. Okay, minus 917. These guys go to 0. Now I have K minus 917 on this side, and I have 6W plus 6H minus 6A over on this side. So just keep in mind we're going to isolate the 6W, so why don't we just add 6A to both sides now? Plus 6A plus 6A. These guys go to 0, and I get K minus 917 plus 6A equals 6W plus 6H. All right, we play this game one more time just to toss the 6H over there. So we subtract 6H from both sides.
Just work our way down the line.
Yeah, that's it. You know, and really like...
Just to flip it to the other side, I mean...
Yeah, that's all we're doing. Yeah, we're just flipping terms if you want to keep it that way. Flipping terms. Sounds like I'm mad at terms too. Flipping terms.
I'll flip you then.
Okay, so now we have 6W over here. Once again, like always, we just divide by the coefficient. So we have all that junk over 6.
I was going to say, I'm not your coefficient father.
All right, so yeah, there's two ways to tackle that. You know, just as long as we all end up at roughly the same spot. You'll notice that the answers are slightly different, and that the other one had a negative sign in front, and all the signs of these guys were switched. You know, but it's still the same exact answer, and I'll recognize it as that. All right, so let's do some more examples here. So here are, let's see now, this is in section 2.3. There are step-by-step instructions on how to solve a formula for a given variable. Definitely feel free to study those and use them if you want. You know, I kind of do a little less formal stuff, but if you like formal step-by-step exact instructions, it's a good place to go. Okay, so this is an important one. So we have the surface area of a right circular cylinder. The surface area A of a right circular cylinder of a height h and radius r. They want us to solve for pi. So we're going to note that pi exists in two different terms up here. This is a case that's going to be on the next exam, right? Absolutely. It'll probably be on at least 2 of the exams. Probably be on the final too. Just, this is something you guys need to know, basically. Like, you know, it's going to come up in 105 and 151 like at least 40 times, 50, 100 times, I don't know. So how this works is if you have to solve for something that's contained in 2 different terms, we have to factor that term out. Remember factoring? So remember, to factor, you know, just a simple example of factoring would be 3x plus 3. Right? We know 3 is a common factor, so we can pull it out. Yep, and then write what's left, x plus 1. Okay, so that's the same thing we're about to do to pi right here. So we have a equals. Now we're going to pull that pi out.
Wow.
I'm sorry. Like I said, the drop date's tomorrow. Okay, so I pull the pi out and then I write what's left. 2r squared and 2h, right? Okay, now we're actually solving for pi. Just because pi is actually a number, that doesn't mean that we can't solve for it. Kevin, you like that, huh? I know you like that joke. All right. So just like we would do for x, right? All this stuff is attached to the pi, so we treat that like it's a coefficient of pi, and we just divide both sides by all that junk. So divide by 2h plus 2r squared, divide by 2h plus 2r squared. Then we're going to rewrite our results so it looks nice. So I have pi equals a over 2h plus 2r squared. Now, if you reach the homework assignment and you forgot how to do that one, that's totally okay. That's something that it requires some practice. That's weird, you know, like you guys watch me do it up here and you're probably like, oh, I see. But as you guys know, when you get to your homework, sometimes it's not quite that easy. So,
It's like, the heck is this?
oh yeah, and it's like, what? How do I do this? This is madness. All right, so,
This is not what you taught us.
right?
Politics.
Politics. Oh gosh, no, I'd never teach politics. Ugh. All right. So that was the chapter on formulas. So basically, yeah, you just solve for the given variable. Yeah, if you got questions about that, come and see me. All right, so now let's go into the basics of applications with percent. So this right here in the yellow, this is our official percent notation. So this says that n%, I'll write an example over here. Let's say we had 81%. So 81% means n over 100. So this is equal to 81 over 100. It's also equal to n times 1 over 100. So this is also equal to 81 times 1 over 100. It's also equal to n times 0.01. So this is also equal to, whoops. So this is also equal to 0.81. So more or less what this says, especially this last part, this says to turn a percentage into a decimal, you move the decimal point 2 places to the left. So if I have 81% and I want to turn that into a decimal, I say, boom, boom, this is equal to 0.81. All right, if I have 15% and I want to turn that into a decimal, I move this 2 places to the left, this is 0.15. All right, even if it's not like a 2-digit percentage, so if the percentage is 3.4%, I still move it 2 places to the left, 1, 2, which means a 0 gets placed there. So this is equal to 0.034. All right, so here are some examples. 53%, if I move the decimal place 2 to the left, I get 0.53. 4.7%, once again, we move it 1, 2 places to the left, and I get 0.047. 1,400%, just take our little decimal, boom, boom, this is equal to 14. Okay, and we do this because when we say I want 53% of x, right, writing 53% x doesn't really do much. We need something we can punch into our calculator. So 53% of x is calculated by saying 0.53 times x. All right, so that's why we convert them to decimals, so we can use them in our calculators, so things aren't confusing. Okay, so you'll definitely run into examples where it wants you to go the other direction, and so they want to say, suppose we're going to convert this 1.22 into percent form, right? Suppose we have 1.22x, right? It's 1.22 times x, and we want to know what percentage of x that corresponds to. We just reverse the operation of turning percent into decimal. So we take our little decimal, take the decimal, and we move it 2 places to the right instead. So this is equal to 122%. When it's in fraction, we want to put it in decimal first and then convert. So 3/4, that is equal to 0.75. If we want to turn it into percent, we take our little decimal, we move it 2 places to the right, and we get 75. Same thing with 0.7, right? 1, 2 places. That means I have to add a 0. So this is equal to 70. Whoops, I should put percent signs. 70%. All right, any questions on those? Okay. Alrighty. So let's start checking out some percent problems. So things that translate into a percent problem. Percent of typically translates into multiplication. What, when they ask the question what, that usually translates into a variable. Is or was is usually an equals sign. And percentage, we just went over what that translates into. Okay, so when they ask us, what is 11% of 49, we do this just like we translated English to algebra before. What? That's a variable, x. Is, that's an equals sign. 11%, what's that in decimal form?
0.11.
Good, 0.11 times 49. So we can calculate that if we want. 49 times 0.11. Good, 5.39. Okay, same thing with this one. 3, that's just a number, so we write it down. Is, that's an equals sign. 16%, that is 0.16 of what? Multiplied by a variable, x. So 3 equals 0.16x. If we want to solve for x, we can divide both sides by 0.16. And that gives us, nice, 18, x is equal to 18.75. All right, let's try another one. This is kind of a weird one. Oh, okay. So, what percent? So, the percentage is the variable in this case. So, we're just going to say x of, and we'll keep in mind that x is in units of percent, of $50 is 34. Just like always, we want to solve for x, so we're going to divide both sides by the coefficient. 50, 50, what's that equal to? 68, so 0.68. So x is equal to 0.68, that means we have 68%. Okay. All right, so let's do some more word problems here. So in 2012, the city of Chicago had designated 200 miles of bike lanes. The number of miles of bike lanes planned for Chicago by 2020 was 322.5% of the miles in 2012. If all the planned lanes are completed, how many miles of bike lanes will Chicago have in 2020? Okay, so basically they say, well, we start out with a base of 200. We want 322.5% of that, and that's going to tell us how many bike lanes we should have. So we say, basically, and so we'll put this into a sentence, right? So they say 200 miles is 322.5% of what? All right, so 200 miles, 200 is equal to 322%, and actually I'll throw that into decimal form. What's 322.5% in decimal form?
32,250.
Other way. There you go. Yeah, you're moving the decimal the wrong way. So yeah, so 3.225. Boom, 3.225.
2 spots.
Yeah, just 2 spots to the left, right? Of what is our variable, right? So of is the multiplication, and what is our variable. All right, just like we've done in the previous however many problems, we're going to divide both sides by the coefficient attached to x. And I'm counting on you guys out there with the calculators to help me avoid this work. 62.01. Sure, why not? Actually, that doesn't make so much sense, though.
That's what I got. The total mile of road it would be 651.
Yeah, I think it's asking a different question than what you're answering.
Did I set that up incorrectly? 200 miles is, oh!
Yeah.
See, you guys gotta watch me.
Once again.
I know. I actually wish I could blame that on you guys, but I can't. Good, good. Okay, so they're asking us something else. So what are they asking us? 200 miles. No, they're saying, okay, they're saying.
Show us the link.
They're saying the new bike paths are new. How do we write this in a sentence even? I'm trying to think of correct English.
I just multiplied 200 times 325.
I mean, yeah, that's maybe I could reverse engineer that. I mean, that's definitely the setup. So 3.225 times x, no, times 200, sorry, times 200 is equal to x. There we go. So that's the setup. So they're saying 322.5% of current paths is the new amount of paths or whatever. Honestly, if you just write this, I'll be much more happy. All right, so what was our final tally on that one? 651. 651. So on that last one, this is a teachable moment. When we reached the end of that last one, we had like 60 something, right? And then if you look at the original problem, they already had 200 miles of bike lane, right? There's no way 322% of 200 is less than 200. So obviously I did something wrong. You guys saw that. So yeah, that's a good lesson to, like, yeah, just analyze your answer. Make sure it makes sense. All right. So let's do this one. So college enrollment. So about 1.962 million U.S. students who graduated from high school in 2013 were attending college in the fall of 2013. This was 65.9% of all 2013 high school students, the lowest percentage in a decade. How many students graduated from high school in 2013? Okay, so all right, so for this one, they give us this value, 1.962 million, and they tell us what that value is. And then they say this value was 65.9% of all 2013 high school graduates. And they want to know, that's the variable, right? They want to know how many students graduated from high school in 2013. So we have 1.962 million equals 65, whoops, let me convert this into decimal, equals 0.659 times our variable, which is the number of high school graduates, the total number. Okay, so divide by the coefficient, 0.659, 0.659. What do we get there? An ugly number, it looks like. Did you guys get something ugly? Yeah? Okay. We're going to round this guy. So, we're going to round it. Every time we round a number, we have to make sure to give these little squiggly equals signs to say it's roughly equal to. Yeah, we're going to say this is equal to 2.98 million. All right, so if we wanted to fully write this out, we would say approximately 2.98 million high school students graduated in 2013.
I have one problem.
What's up, Gabe?
How could the total number of graduates be more than the people who entered high school?
So they actually entered, they were attending college.
Oh.
Right, and so it's one, yeah, winnowed some down. Good point, all right? We got to analyze that problem. All right. Does anybody know what this word is? Promotion. Promotion.
Oh, Ronaldinho. That is awesome.
Oh, man.
How long did you put this together?
Hours.
Valentino.
No, when I do the examples, like I really just try and type them out as fast as possible, and I screw them up too often. I deserve it, though. I deserve it. All right. Keeps you guys on your toes, right?
Together. Well, he does it like in 5 minutes. You don't really care about it.
I take a long time with the explanations, like of the little demonstrations, and like when I over-explain everything, that's when I take a lot of time. But then I'm like, oh, examples. Like, let's just get this done. All right. So during a recent promotion, Fitting Footwear reduced the price of a pair of running shoes from $139 to $114. What percent of the regular price does the sale price represent? All right, so we have what percent? That's got to be X of, that should be times the regular price. The regular price was $139. Does the sale price represent? Okay, equals the sale price, 114. Okay, so we go ahead and divide by the coefficient, 139, 139, and this is equal to, this is equal to roughly 0.82. So the sale price was roughly 82% of the original price. Now they want to know what percent was the discount. We can handle this two different ways. The first way, we could subtract 114 from 139 and then analyze what percent. Actually, we'll just do it both ways. So the first way, we're going to say what percent is the discount. So one way to find that is to first find out how much the discount was. So we have 139 minus 114. Is that 25? Yeah. Excellent. So we can say what percent. Actually, we'll just set up the darn equation. So we can say what percent is 25 of the regular price. So it's basically the same setup that we had there. So X times the regular price, 139, is equal to 25. So right, so we're saying X percent of 139 is equal to 25. Now we divide both sides by 139. and we get something roughly equal to 18%. So the other way to do that is to just remember that 100% of the item is 139. If the sale price represents 82%, that's 100 minus 82. The discount is 18%. So that's the easier way to do it. All right, so that was that, and we do have some time for overtime problems. Lucky you. So these aren't too bad, right? These aren't too bad. Just remember, this guy here, this is an example of that crucial one that I told you guys, remember? Think about factoring when you run into that guy.
60 seconds to self-destruct. If I come across something, can I ask Siri?
No,
Siri's really helpful.
I know, but I don't trust her.
I do.
I drive off a cliff. I trusted her my whole life. This is where the cul-de-sac is.
Right. Ask Siri what the golden ratio is. Yeah.
That'd be kind of good.
I'm curious.
Siri, what is the golden ratio?
I'll probably tell you we'll call it 4.
Oh.
Yeah.
In mathematics, two quantities are in the golden ratio if their ratio is the same as the ratio of their sum to the larger of the two quantities. The figure on the right illustrates.
All right, that's enough. I know that. That's good. Yeah, that's awesome. She's actually got that in there. Nice job, Siri. But you still can't use her, unfortunately.
Well, I just want to see what the answer is for this. Are you single? I'm married to my work.
That's sad.
That's sad.